All right. Hi, period 6. Sorry I'm not here. I'm going to go over the notes with you for 4.8 so you're not falling behind. The fundamental theorem of algebra, as you saw on the video, I hope you guys watched the warm-up video, every polynomial equation p of x equals 0 with degree of n, where n is greater than or equal to 1, has at least one root, either real or complex. Okay. Find the number of complex roots for each polynomial equation, and the way we find it is by using the highest degree that we would normally use to name the polynomial. That would tell us how many roots we have. So we have 3 for number 1, so we're going to have 3 roots. And number 2 has 4th degree, so it's going to be 4 roots. Okay. So it's not always complex. It can be both a combination of roots, so real and complex. So I'm going to go ahead and cross out the complex part. Now, we're going to go through this first example, and then we'll go through 2 more examples together. So try to stay with me on this one. It's a lot of steps. How do you find all the zeros of a polynomial function? Step 1, use the degree of the polynomial to determine the total number of zeros you need to find. So we have x to the 4th power, which is the leading coefficient, which tells us we have 4 zeros. Then we're going to use the rational root theorem to identify possible rational roots. I hope you remember that from the last lesson. And we have the p and the q. P and the q value. P is from the constant coefficient, 20. It doesn't matter whether it's positive or negative because we're going to use both positive and negative values of the factors. So the factors of 20 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. And q values are for the leading coefficient, which is 1. The factors are just 1, plus or minus 1. So if I put each of these factors over 1, I'm going to end up with the possible roots that we would get. So p over q would be plus or minus 1. 1 over 1 is 1. Plus or minus 2 over 1 is 2. Plus or minus 4 over 1 is 4. Plus or minus 5 over 1 is 5. And plus or minus 10 over 1 is 10. And plus or minus 20 over 1 is 20. Okay? Then we're going to use these 12 possible roots to apply in step 3 and step 4. Now, step 3 and 4 can be used with the factoring methods that we learned on 4.2 lesson. Okay, so you can refer to that lesson to figure out which one to use, or you can start. Definitely highly recommend you start by synthesizing the polynomial or using synthetic division to start. This is a guess and check kind of a thing. You can start with 1 and work your way to 20, or you could start at 20 and work your way down to 1. I'm going to start with 1. Another way that we can figure out where the whole number roots might be, so it makes the dividing easier, is by graphing the polynomial on your graphing calculator. Then you can kind of see where your whole number 0 values are, and then you can use that whole number as your divisor for the synthetic division. So my coefficients of the polynomial are in standard form already, and it's in degree order. So we are going to go ahead and start with 1, 4, negative 1, 16, and negative 20. We're going to bring down the 1. 1 times 1 is 1. Add those 2 and get 5. 5 times 1 is 5. Add those 2, we get 4. 4 times 1 is 4. Add those 2, we get 20. And then positive 20 is what we get when we multiply them. So we have a remainder of 0, which means if we have a remainder of 0, this 1 is a root because it is a factor. So the root is 1. So the factor of the polynomial, one of the factor, is going to be x minus 1. Remember, it has to be the opposite of the root. Okay, since the root was 1, the divisor was 1, then the factor has to be written as x minus 1 instead of x plus 1. Now, so one factor we have is x minus 1, and then we have these coefficients as my leftover coefficients. So I'm going to start with x cubed plus 5x squared plus 4x plus 20. Now I need to factor this group of guys. Now we can use, let's see, quadratic formula, we can use square roots method, we can use the grouping method, we can use the substitution method, we can use so many different kinds of method, etc. Now, if it is greater than 4th degree, you may need to use synthetic division twice before you factor with the factoring methods from 4.2 lesson, okay? So let's go ahead and take a look at this. It looks like we have 4 terms, and it starts with 3, 2, 1, 0, so it's in order. There, I think we can use grouping method, so I'm going to go ahead and use x to the 3rd power plus 5x squared as the group, plus 4x plus 20 as my second group, and I still have my x minus 1 as one of the factors. If I were to factor out what these two have in common, it would be x squared, then it'd be x plus 5, plus, and then between these two, I have 4 in common, so it's x plus 5 again. Yay, we do end up with common factors of x plus 5 binomial, so I'm going to go ahead and write that as a separate factor and write down the leftovers, x squared plus 4, and bring down that x minus 1. So now we have 3 factors, but this one still has x squared, so we could probably find a lower, actually, a lower degree factor. So I'm going to set this one up, x squared plus 4. To figure out the root, I have to set this equal to 0. Subtract 4. Divide both sides by, and then we have subtract 4 on both sides, negative 4 on the right side. Take square root of x squared to get x by itself. So square root of negative 4 on the right. We have x equals plus or minus. Since that negative exists inside the radical, it should be imaginary, rad 4, but that rad 4 can also be simplified as 2, so it should be plus or minus 2i. So there's one root, there's another factor that will give us the root, and another one. So if we were to write the polynomial in factored form, you can have it one or two ways. You can write it as x minus 1 times x plus 5 times x squared plus 4. That's one way to write it, equals to 0. Or you can write x minus 1, x plus 5, and then write this as the part of my factor. So x plus 2i and x minus 2i equals to 0. Either one of these will be acceptable way to show factored form of the polynomial that was given to us. And then the last step is to identify all the zeros. To identify the zeros, you start with x equals, and then start with the braces to list all of the possible factors, all the zeros. And that will be positive 1, negative 5, and plus or minus 2i. Oops, wrong brace. There we go. All right, so just the classwork part. This is not considered homework, so please make sure you get this done, okay? So 2x cubed minus 11x squared plus 12x plus 9 equals 0. So the expected number of zeros is 3. Make sure at the end you have 3 roots, okay? The possible roots are p over q. P value is 9. So the factors of 9 are plus or minus 1, plus or minus 3, and plus or minus 9. Q values are 2, so plus or minus 1 and plus or minus 2 for the factors of 2. So if we put P over Q, then we would have plus or minus 1 over 1 is 1, plus or minus 3 over 1 is 3, plus or minus 9 over 1 is 9, and then plus or minus. The rest will be in fractions because none of them are divisible by 2, so it'd be plus or minus 1/2, plus or minus 3 halves, and plus or minus 9/2. Okay, so we have possibility of 6 different possible roots. So let's go ahead and start with our root. Now we could use 1 and try it out, and we will have a remainder. We could try -1 and we'll have a remainder. I already know this because I've done it so many times. You can also find out by putting in this expression into your graphing calculator where it says y equals on the button and graph it. Then you can see where they cross on the x-axis to figure out if there's a whole number that works. And in this case, 3 works. So I'm going to go ahead and do 3, 2, -11, 12, and 9. When we plug in 2, we drop the 2. 2 times 3 is 6. -5 is what I get. -5 times 3 is -15. 12 plus -15 is -3. -3 times 3 is -9. If you need me to slow down, just rewind it and then watch it again, how I got that. So now that I see this, my root can be identified as 3. And then the factor, which is the divisor binomial, would be minus 3. Okay. So using this, I have x minus 3, and the other part of the polynomial we have left is 2x squared, 1 less than what we started with, minus 5x minus 3. It's a trinomial, quadratic trinomial, so we could use the box and the x. So x box. I'm going to put 2x squared and -3, -6x squared, and -5x. So my factors are -6x and positive 1x. Then I would have -6x and positive 1x. So they have 2x in common and 1 in common, positive 1. And then we have x's in common and -3. So I have the first -3 that we got from here. Okay. And then we have another one that we just found from using the x box, x minus 3. So there should be 2 binomials that are identical, x minus 3 times x minus 3, and then a 2x plus 1. There's nothing else to factor, so we're going to move right into writing it into factored form, which is x minus 3 times 2x plus 1, or, equals to 0, or x minus 3 quantity squared times 2x plus 1 equals to 0. You can do either one of those. When I identify the zeros, I'm going to have twice. This one lands on the x-axis twice. And then we have the 2x plus 1. 2x plus 1, if I were to write it as a root, it would be 2x equals -1, and then x would equal to -1/2. So it would be -1/2. Should be opposite of whatever sign it gives you for the operation, and then b over a. Okay, so that's the second one. If you need to go back and take a look one more time or copy it down, go ahead and pause the video and continue working to make that up. All right, so here we go, 4. So this is 4th degree, so there should be 4 zeros. The possible roots are, sorry about that. Possible roots are for 8. Remember, it doesn't matter if it's positive or -8 because we're going to have plus or minus of each of those values for 8. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And then the Q values will be plus or minus 1 and plus or minus 5. So everyone is going to have P over Q, everything over 1, so plus or minus 1 over 1 is 1, plus or minus 2 over 1 is 2, plus or minus 4 over 1 is 4, and plus or minus 8 over 1 is 8. Okay, so, and then another set would be by putting 5 underneath each of these factors from 8. So 1 over 5, plus or minus 2 over 5, and plus or minus 4 over 5, and last one, plus or minus 8 over 5. Okay, so now we're going to use one of these factors and find the root by synthetic. All right, so to find a root and synthetic division, I need to, I need to use a root that would work for this polynomial. So I'm going to try 1. Okay, and then I need to write out the polynomial coefficients to the right of it. But if we are missing 1 or 2 variables coefficient, we need to place it with 0. So it goes from x to the 4th power, then x squared minus 8. So we're going to use 5 for the x to the 4th power, 0 since we don't have x cubed, and then sorry about that, and then 0 for x cubed, and then 3 for x squared, and then 0 again for x because we're missing an x there, and then minus 8. So it should be 5, 0, 3, 0, negative 8. Okay, bring down the 5. 5 times 1 is 5. 0 plus 5 is 5. 5 times 1 is 5. That's 8. 8 times 1 is 8. And I can bring down an 8. 8 times 1 again is 8 and end up getting a remainder of 0. So my root is 1. And then my factor is going to be x minus 1. So if I were to write it out, x minus 1, then the polynomial will be 5x cubed, since it's the next degree down from x to the 4th power, plus 5x squared, plus 8x, plus 8. Now, if you miss those zeros, you're going to end up with only 2 terms instead of 4. So that's why it's really important that you guys fill these empty spots with zeros, okay? Now we're going to break these guys down, and I think grouping method would work again for this one because 5x cubed and 5x squared has 5x squared in common, and 8x and 8 have 8 in common. So I think that'll work. So here's x minus 1. Then I'm going to group 5x cubed plus 5x squared together. Actually, this should be doubled. Not this one though. Plus 8x plus 8 needs to be in its own group, and then the last parentheses that'll match this one. Okay. Now I'm going to factor out what they have in common, which is 5x squared, x squared. Sorry, x squared should be factored out, and I should have just x left over inside the quantity, plus 1 plus 8 times the quantity of x plus 1. Now we have x plus 1 and x plus 1 in common, and then we would have x plus 1 taken out as a common factor, and then writing out the remaining, the leftover pieces from the factoring as 5x squared plus 8. Now we still need to find a root for 5x squared plus 8, so I'm going to shrink it down just a tad so I have some room to do one more factoring to figure out the roots of 5x plus 8. So to 5x squared plus 8. So 5x squared plus 8 is going to equal 0. We're going to subtract 8 on both sides. Then we have 5x squared equals negative 8. Divide both sides by 5. We get x squared equals negative 8/5. So take square root of x squared and take square root of negative 8/5. That negative turns into an imaginary, so I have x equals plus or minus imaginary of 8/5. Now this should be rationalized where there's no more radical for the denominator. At this point where I have it here, it actually means square root of 8 over square root of 5. So I have, I can show you how to rationalize that later, but I did show you very briefly earlier in the unit. So I'm just going to go ahead and write it as it is. So here's the factored form, x minus 1 times x plus 1. And then the second one should be, let's see, Oh, we can write it as 5x squared plus 8 in factored form, and all of that equal to 0. Or we can use this to write it in factor form, x minus 1, x plus 1, and then put x plus imaginary I, rad 8/5, times x minus imaginary times rad 8/5. You can write it like that too. I think this looks cleaner, so I'm totally okay with that one. But if this makes if it's easier for you to identify the zeros by using it this way, that's totally fine too. So let's go ahead and identify the zeros. We have a positive 1 and a negative 1. And then we have positive and negative versions of the imaginary times the radical of 8/5. Close the braces. And that's it for notes. Go ahead and work on your 4.8 homework, which is on the next page of this. It is challenging. I highly recommend you use your graphing calculator to graph to figure out the whole number terms as you approach step 3 on any of the problems that you have for your practice. The best way to get better at this is wholly by practice. So please try to practice as much as you can. Thanks, everyone. I'll see you guys on Wednesday.